بسم الله الرحمن الرحيم. In this lecture, we will design, build, and test a complete embedded system, both hardware and software. We use the round robin software architecture for the software part, and we'll use the Arduino platform for the hardware. So we'll have fun designing real things or something close to real things. In order to complete this design, you need to recall all what you have known and practiced so far. You need to recall your knowledge of C programming, in particular the processing version for Arduino. You need to recall your hands-on experience of connecting switches and LEDs to the Arduino. And you need to recall your knowledge of round robin software architecture and the art of designing task codes for the round robin architecture, which we have so far practiced for some time. Just a quick reminder to you of the different approaches to building software in embedded systems. We have discussed 4 types of software approaches, and the first one was the Arduino the round robin software architecture, and this is the case for which we will use. This is the approach that we will use in today's practical example, and this is the simplest of all the 4 approaches, but the worst in response, though it can work very well in many cases. Other approaches: the round robin, same round robin, we add to it interrupts. So we'll have number 2 round robin with interrupts, and this has a better response because urgent needs of task codes are dealt in interrupt service routines, as we discussed. In number 3, we have divided the tasks into number of functions, and these functions are queued, so task codes are prioritized as well, and so we can have a better response. And the best response is of number 4 when we use a real-time operating system, because we can even stop a task in the middle, so we have the best response to prioritized things, to prioritized events and tasks and so on. This is a slide from a previous lecture, just to remind you of what round robin is. As you see, in round robin, all the tasks are cyclically run by the main code, one after the other, one after one. So no priority is given to any task over the other task codes. Any of these tasks, for example, task 1, will check to see if there is a ready input for it. Of course, this input, as you know, can be from a switch, a sensor, a timer, and so on, a peripheral device, or a timer inside the microcontroller. If so, if there is an input, the task will be run. So this is true for task 2, task 3. So what's the main problem? As you notice, the main problem will be delay in response, because if there is an input to any one task, this input can be processed, can sometimes be processed with delay. I mean, they can be delayed in processing up to one full cycle. All the other tasks and even the same task have to run. This is maximum, of course. Depends on which instance the input happened. But as you recall, we discussed that our design should be based on worst case, not the worst case for response. The main thing which makes round robin tempting is its simplicity. So that's why it's used in many applications, especially when response is not an issue, or when the number of tasks and the processing power is enough to deal with external events timing requirements. All right, so first we need to determine what our system is. So I'm here describing what the system should do, and we call this functional requirements. So our system is about car doors lights control. So it means that we need to control the interior lights and signal lights, left, right, off, left door, right door, and so on, back door in a car. Of course, for simplicity, I'm using 2 doors only. So I'm assuming a car with 2 doors. You can extend to any number of doors. So we will have, of course, what we will have, we'll have interior light, cabinet light, and we'll have signaling LEDs. What I mean by signaling LEDs, a left LED and right LED, left door, right door. So when you know which door is not tightly closed or not closed at all. So this is you are familiar with such systems in your car. So I have subdivided this mission of controlling the interior light, the cabinet light, and the signaling LEDs into 3 tasks. Of course, these tasks can be translated, if you find it okay, to task codes immediately. And in this case, of course, you can programming task codes in the program can be slightly different. You start up. This is the description given you by the customer, who has some requirements. But in general, roughly you can translate these into program task codes, but it's not a must. In this case, I designed the tasks here to translate immediately into task codes. So task 1 and task 2. Task 1 is related to left door, and task 2 is related to right door. You can have task 3 if you have, and task 4 if you have back left door and back right door. So task 1 is what is task 1? When left door is open, when left door switch is on, this means that the door is open or not tightly closed. So left door is open, the left door switch will become on. This is my selection. Of course, we discussed that before. You can have positive logic or negative logic. When the door is open, you can have the switch on or have a switch change from off to on or from on to off. You can deal with this in the program, and we discussed why and which is better, and to choose which approach is to choose. In many cases it's just arbitrary or depends on the switches you have, the mechanical switches you have. So when the switch is on, it means door is open. What we need to do, we need to have the car light, interior light, the cabinet to be on. The light in the ceiling, the car ceiling. And we need to have the left door left LED to be on. Of course, this means that left door is not tightly closed. Similarly, we have task 2, but in this case, we'll have another switch, call it right door switch, and we didn't call it yet. I think we'll call it in the program. We'll name it in the program. Okay, so again, same thing, the car interior light will be on. And so in both cases, if any of the two doors are open, the car interior light should be on, and right LED is on to signal that the right door is not tightly closed. Now task 3. In task 3, this is about the car interior light, switching off the car interior light. When both left door switch and right door switch are off, both doors, which means that both doors are closed, car interior light is off, and both LEDs should be off. So, of course, in task 1 and task 2, I have put that else right LED door is off, else right LED door. So task 1 and task 2, by this description, they are enough to turn off the left and right LED. But turning off the interior light should be something we have put it in a different task, because we cannot turn it off in task 2, because the interior light could be on because of task 1, or because of task 2, or because of both doors, task 1 and 2 are open. So we need a special task to turn it off. Of course, here I've selected pins on the LED, on the Arduino, just that we all have the same, but it's up to you, it's not an issue. So left LED is connected to pin 3. Right LED, we'll use the same symbols here. Right LED is connected to pin 4. They are, as you remember, digital inputs. And pin 5 is used for the interior light, and use some like white LED. Of course, I should have added here in the comment the switches where they will be connected, but I think they are given in the example. But this is the type of comments you should have. You should have in your at the beginning of your code. Look, this is a big comment in Arduino, starting with this slash star and should end with star slash, as you recall. It is missing here. Yes, no problem. In here I show how you should be familiar with this, how I connect the LEDs and switches. I have, of course, you know that I have 3 LEDs, 1, 2, 3. This is with each LED is connected through a proper resistor to ground, common ground, and this is going to the Arduino. I need to connect the anode, the long lead of the LED. This is one LED. Let's assume this is the LED for the interior light, and this is the LED for the right LED, and this is the LED for the left LED. This should go to pin 3. This should go to pin 4. I'm sorry, the light should go to pin 5. This go to pin 4 and to pin 3. Let's do it. So this is going to pin, and this is the right LED to pin 4, and this is the interior light to pin 5. Now to the switches. How to connect the switches. As you recall, we described the different methods of connecting the switches. Using a pull-up resistor, without a pull-up resistor. So we'll use the pull-up resistor, I think. Because not all embedded systems have internal pull-up resistors like the Arduino, although it simplifies interconnection. I'll use the traditional method with external pull-up resistor. So this is my resistor to ground, say like 10K or so, and my switch, which is normally open, to VCC, 5 volt. So we need the 5 volt line on the Arduino or on the breadboard. We need to connect it to VCC on the switch. This is my ground, and we use the VCC on the other side of the Arduino, for example, or VCC, this VCC. I connect it to the breadboard just because it's easier. This is one line with many holes, I can connect many switches to the 5 volt line. So in fact, the switches you have are double switch. The switches you have are double switches, so there are 2 switches in one switch. Using one push, you can make 2 switches on and off. Of course, we'll use 2 points on each switch. one switch in each of these two switches. So each point has to go, one point has to go to VCC, one point has to go to the input pin, like pin 9, as we said, for example. So this is to VCC, same, and so this is again my jumper to VCC, or my connection to VCC, or the first switch, and this is another jumper of the second switch to VCC. The second point should go to pin 9, as we said, we select 9 and 10. The second one goes to 10, digital input. So of course 9 and 10 has to be programmed as inputs. 3, 4, and 5 has to be programmed or configured as outputs. So this is the left and this is the right switch. Of course, the second point of the switch is going to 9, and at the same time is connected to the resistor. So we need to make from a jumper from this same point to a resistor. This resistor going to ground. And I do the same thing for the other switch. I need 2 resistors. So this is now we have all the inputs and outputs are connected, and we simulated the car case switches. I mean it's hardware. So this is, as you see, this is what so this is the left switch. So I'll use the same name of the switch as I'll use earlier. I should short it like LS, short for left switch, so to make it easier in the program. So and this is the other one, the right switch. Now the 2 red lights, one is the left and one is the right. So this is the left LED. This is how I'll use it in the program. And this is RLED, and this is how I'll use it in the program. And the green one, sorry, I don't have a white LED, so I'll use LT to mean light, the interior light, the lamp inside the car. So these all of these switches and LEDs has to be defined in the setup, configured. For example, 3, 4, 5 pins has to be configured as output, and 9 and 10 has to be configured as input. Okay, so this is the program again, and the same comments at the beginning, because it is good programming style to have all the notes and a description of the code at the beginning of the code. So we have here just a description of the code, what it does, what it doing, and so on. Of course, left LED, we called it what we have called it. I think left LL, isn't it? Let's check. It's LED. So the right LED to pin 4, and we called it RLED. The interior light, we called it, as you remember, LT light. L and T. LT. Is connected to pin 5. This is white LED. We are not using white LED. Of course, we can use white or whatever you like. Okay, now switches. Left switch, LS, we called it LS on pin 9. The right switch is connected to pin 10. Right switch, we used RS. Just make your comments clear. Sometimes I like to use the long names, right switch and left switch, but today I'll use RS and LS. Okay, coming to the setup, we have to define some global variables and some constants. What do we mean by global variables? It's like any C program, and in C we can have local, we can have global variables. So if we define a variable inside between within a certain block between two parentheses like this, the scope of the variable will be between these two parentheses. But if we define another variable in another two parentheses, it will be defined in the other two, in the other block. But we need to define it global, so we define it at the beginning. We need them to be known all over the code. So that's why we define them in the setup part at the very beginning. Of course, you remember it is LLED. I was using green and red LED. So these are global. Wherever you write them, you can use them any part of the code. Of course, these are global constants, and these global constants are given the values 3, 4, and 5. This simplifies life, as we discussed before. Once you need to change your circuits using pin 7 instead of pin 5, you just change it here. Okay, if we need, this is a big comment, and starts with / star and ends with star backslash. So the next section is the setup. I was using the old names, I changed now. So I'll use LLED, and LLED is defined as output. Of course, RLED is also output, and light also is an output. Now we define the switches. Pin 9. and pin 10. Let's give them an initial value in the variables and constants, in the global variables and constants section. So left switch is 9 and right switch is 10. I've defined them as integers. It's okay, because 0 and 1 can be 0 and 1 are integers. So 0 is for off, 1 for on. So I use pin mode again to define my left switch and right switch as outputs, as inputs, sorry. So I added a comment. Now it's good to learn to so this is setup comment, setup of door switches. It's good to use comments in appropriate size, not too much, not too detailed, but enough comments. So this is pin mode for left switch as input, pin mode for right switch as output. This is how we define as input, sorry. This is how we define inputs, digital inputs. Okay. Now we will move to the coding part, but before we do the coding, let's go over this slide from a previous lecture, which shows the structure of the coding. Just a reminder to you. It's already annotated. This is the main loop, while true in general C, or in processing of Arduino you can say loop, and simply it will go on and on forever. So this is an infinite loop, and we have 3 tasks: task A, task B, task C, running all the time. Now, for any task to check whether it has an input, we can use an if statement. If some I/O device, some switch, in our case switch A on switch B, is activated or needs service, then you do whatever, take care of I/O device A. Whatever device A needs to be serviced by, and and sometimes you need to send something to the output, like sending data to device A. Similarly for task B, which is associated with, for example, I/O device B. If this device needs service, then you do whatever needed to serve device B, and you do whatever needed as output to device B or whatever. Similarly for device C. Okay, let's now try to do the actual programming. Task 1, start with task 1 in the main, and we start with task 1 case, the left switch case. So we said at the beginning of each task code, we need to check the input from the switch. So in this case, we need a variable that we will store it in it the value of reading of left switch. So we need to read the switch, digital read left switch, and we put it in some variable. So let's name this variable, for example, left switch status. Left switch status. So this variable, we have to define it, and we use an assignment statement to assign the reading of the left switch to ls status. The variable is called ls status. Now we use an if statement to check the status of the left switch. Of course, we need to define this variable. So we can define it as global if you want, but there is no need here. We can define inside the loop. So left switch status, and of course we will need a right switch status. So these two variables are not constants, of course, because they will hold the switch status 1 or 0, high or low. So we define them as integers. So in the if statement, if left switch status or ls status is high, what we will do, of course, if left switch status is high, it means the left door is open. This is a comment, and in this case, what shall we do? We have two things to do. First, we need to switch on the internal light. So we can use digital light high, digital light ls high. Of course, in Arduino this should be capital high. So notice the color code in Arduino, it's very helpful. Okay, we need a semicolon up there. So again, we need digital right. Okay, now it's red. Light, we need to put it as high. So we can add the appropriate comment. This term, the left LED on, and this turn internal light on. What if the left switch, if the door is not open? Else we need to turn off the left LED. We will not turn off the interior light because we left this to task 3, remember? So else left door is closed. In that case, we need to say digital right. We need to turn off the left LED, LS, put it to low. This is a comment. This turns off left LED. So this ends task 1. We can copy task 1 and we use it in task 2, but just copy paste and we edit it appropriately. Okay, now just we replace left switch case with the right switch case in the comment, and we'll use right switch status بدل LSRS instead of LSRS, and right switch status, if right switch status, we defined right switch status variable, then right door is open, and LS we replace by RS, turn in the comment, turn right, and the second line should remain the same, no change. So in the else it means the comment right door is closed, and in this case we replace LS by RS. Oh, we made a mistake. It should be right LED, not RS. Oh, and of course we have done the same mistake all over above in task 1 and task 2, because it is we were trying to write something to an input to a switch, left switch and right switch. I meant right LED and left LED, so we must correct this also. This should be LED, left LED, LLED, and where else? Okay, now we write task 3, task 3. Now task 3, if the two switches are off, or the two doors, we forgot to read the switch for task 2. Oh no, we have it. We have it. This is digital read RS. The two switches are read in task 1 and task 2. So in task 3, what we do in task 3. So let's write a comment about task 3. This task 3, it does turn off interior light, provided that the reading of the right switch and left switch are off, both doors are closed. So the condition for running this task is that both switches are off. So we need an if statement. Oh, we forget also to add parentheses, curly parentheses after the if statement, because there is more than one line, so we need parentheses. Yeah, we add the parentheses, 2 parentheses after the if. So after the else, actually there is one line, we don't need parentheses, but no harm if you add parentheses. So task 3, right? If the condition, if right switch is low and left switch is low. How we write this in C? If switch left, LS, left switch, if LS is equals low, and how do you write and in C? Yes, bands, 2 ampere symbols. Okay, and RS, if left switch and RS equal high, of course we have to have 2 equal signs for, even we need to add another equal sign for logical comparison. Low, close. If this condition is true, we need, you can add also parentheses, internal parentheses, although it's not really a must here, but I like to add them for clarity purposes, although I don't really need them because comparison has higher priority. So what will be done is that what is inside the 2 parentheses is done first, comparing RS with low, comparing LS with low, then adding the result. If the result is true, both are low, what we will do right now, what we will do in this case. Okay, so we use 2 parentheses, just inside it one statement, just to set the light to low, the interior light to low, or digital right LT low. This add a comment. This instruction turns off the interior light. Now I believe this code is okay. Now we will run and check if there are mistakes. Of course, first we will come to the syntax mistakes, a missing comma, semicolon, or error in the syntax or the spelling of a command, or undefined variable. So these are the syntax errors, type of syntax errors. So we'll check first. When we run, we'll see if there are syntax errors. Missing parentheses, missing comma, semicolon, as I said. And then there will be the logical errors. So let's first run it. Control R, it will run the code. So we are having some missing semicolons. Look at the red line. Now compile. What's wrong here now? Expected initializer before talking. So what does this mean? We are missing something, not a semicolon. This is a comma. Yeah, it should be a comma. This is not the cause of the problem. ls status is not defined. So ls status is not defined, is not known, because there was a mistake in using the variable inside. So we are still doing the syntax errors. There's an expected unqualified ID before else. So what's wrong? Go. So what's wrong? Unqualified ID before else. So what's wrong? So missing closing parenthesis. So I hope we end up now with our program is free of syntax errors. Now generated the machine code. We need to send this to the processor, to the Arduino. So we need to do upload. Use this arrow, this means upload. Now the program, the machine code is sent to the processor. We'll check if it is running correctly. If not, then we have some logical error in thinking, or some error that is not a syntax error to be detected by the compiler. Oh, now yes, okay, we have here, this is again, we did not correct this. We cannot write to an output. Actually we can in embedded systems, because we write to the port, not to the output itself. But this is what I meant today. So we need, this should be left LED, LLED, not LS. We corrected that for the right, but we forget. And here LT, yeah, LT is correct. Here let's check again. Digital right, RLED. We did not correct this all over. This is right LED, this is correct. And nothing wrong with this last. Light is low, yeah, it's okay. Now let's compile again, because we did many changes. Now I have the left LED running nice and smooth, but still I have problem with the right LED. Let's see what logical error we have. Sometimes, yeah, it is my mistake in inserting the wire in the breadboard. I inserted in a hole not the correct hole. Now everything almost correct. Now the only thing is that the interior light does not switch off. Let's see. Let's check task 3. Oh, we have blunder error in programming. This is here. Digital light. Oh no, here. If LS equals low or RS equals low, LS and RS are the switches, but we should have used this LS status variable and the RS status variable. So the status of switch LS or the switch RS is stored and read into a variable called LS status or RS status. So I have two solutions. Either I reread them before task 30, but they are already read in task 1 and task 2. So in task 1, in this instruction we have read left switch, and in this instruction we have read RS. So no need to read them again. And we have read them in the same loop, and the loop is running at fast speed. So the only thing we need to do here, if LS status, not LS, equals low, we need to mind the capital and smaller, same as we defined it, equals low, and RS equals RS status equals low, turn off the interior light. So I believe now everything is correct, and we can run the program now. Okay, so I run, and I will have a video of the switches and the board, and you see just give me a second. I think, yeah, it's okay now. Yeah, it's okay and running. Just yeah, it's okay. I will so this ends the practical example. I will just attach a video clip to this of the resulting circuit and its operation. So yeah, I'm checking everything is okay. So again, I stress this, that we are reading LS status, we are storing the switch status in LS status and RS status. So this is correction of the lecture number. Sorry, I did a mistake in numbering, and okay. Now this is my circuit again, and the yellow button represents the right switch, the red button the left switch, and the LED, the red LED close to each of these is the corresponding LED switch, and the one in the middle is the interior light. Now if I press on the yellow button, the two lights are on, the interior light and the LED, corresponding LED, right LED. So I removed my hand, they are off, two doors are closed. Same thing for the left switch and the corresponding LED. Now if I press the yellow again, the light in the middle is on, the interior light, and the corresponding LED. Now two doors closed, everything is off. Same again, I repeat, just for the left, the same thing. Now if I press, I'll press both, so two doors are open, so all LEDs, the two LEDs. Now if I remove my hand on, again the interior light is on. The two doors has to be off to turn off the LED, I mean the interior light of task 3. Thank you.